Hello everyone. In this tutorial, we're going to look at how we can look at a data set, which is basically the very first level of data wrangling in R or in any data analysis exercise. So what we're going to look at in this tutorial is basically how we can start the primary screening once you get a data set, and how we can start the primary screening of the data set. So let's say we have a data set which is, if you have a really small data set, let's say it has some 50 rows and let's say 5 columns. In that kind of data set, it's really easy to take a look at it, like the entire data set. For example, let's say we can load cars data set. And if you click on that, data set, it has only 2 columns. One is speed, other one is dist. Probably it means distance. And it has total 50 rows. And you can like look at the entire data set. It's really small data. But in most of the cases, when you work on a practical data project or data science or data analytics project, you will see the data sets they will contain thousands or millions of rows and hundreds of columns, or at least more than 20-30 columns. In that case, it's really not the best way to look at the raw data set. So in that case, we have some tools, we have some functions that makes it really easy. They give us an aggregated view on the data. So we're going to look at some of those functions in this tutorial. The data that we're going to use for the purpose, it's called air quality data. So it comes along with the base data, base R setup. So we have it. So I've run that code. So here, if I click on that, go to that data set, we can see it's still manageable, a small data set, but still it is better than just 2 columns and 50 rows. So it has total, how many? 6 columns. And how many rows we can look at here? It has 153 observations, meaning 153 rows, and 6 variables, meaning it has 6 columns, or in the language of machine learning, 6 features. But there are things that we can do to learn how many rows and columns it has. And the first function that we're going to look at, so we want to see number of calls and rows. So we can already see that how many rows and how many columns this data set has. But there's a benefit of doing that using function. So we're going to talk about that. So the function that we're going to use to know the dimension of the data set, dimension of the data frame. By dimension, it means the number of rows and number of columns, actually. Now we can see it shows 153. So the first value is the rows, and second value is the number of columns. So the benefit of using that kind of functions to derive the numbers of rows and numbers of columns is that you can use that inside a function. So let's say for some calculation, let's say you are writing a function, and inside that function you need to know the number of rows or number of columns that a data frame has, because you want to use that number to do some calculations. So let's say how we can do that. So in dim air quality, we see it returns a list of values. It has only 2 elements in the list. So if you want to look at the first element, which is number of rows, we can give 1 inside a bracket and then run the code, and we get 153. Similarly, if we want to look at the number of columns, we can give it 2, and then it's going to provide us number of columns. And then we can use that to do some calculations. Let's say we're going to multiply the total number of columns of that data frame by 2. So the result is 12. So this is basically a very basic benefit of using a function to derive the total numbers of your rows and total number of columns that you have in your data frame. On the next step, so maybe you have really huge data frame, but still you would like to, when you start working with the data frame or data set, you would like to look at the actual data. So one way, very direct way that we always do since in these tutorials, since we have really small data set, we can click on these files, and then it is going to populate. It's going to show the entire data set here, and then we can click on this icon, and it's going to pop up in a separate window. We can enlarge the window and look at the data set more clearly. But the problem is if you have really large data set, this process is going to be really slow. R is not the visually it's not that fast. It's not that friendly. The reason is that it has to load the file in its working directory, and it doesn't work really well with a large data set. So in that case, what you can do is basically you can take benefit of using different functions. You can take a look at a sample. So very basic, one of the first commands that you can use is called head. So head means when you provide a data set inside head, it's going to show us the first 6 lines by default. So if I run that code, I see it has first 6 rows from the data set. It's showing me that. And also you can control how many lines you want to look at. Let's say probably you want to look at first 100, first 10. Give it 10, it's going to show 10. So if you give it 100, 1,000, 10,000, it's going to print all those numbers of rows that you want to look at. Similarly, we can also look at the ending lines, ending rows of the data set. Their quality, and then if you leave that, it's going to print out the last 6 columns or rows, and you can give it some number. Let's say again 10. This is going to print out last 10 rows from the data frame. So one of the biggest uses of these head and tail functions is that a lot of times you'll see, especially if you copy data from Excel or you are using some Excel file, sometimes in Excel files at the tail of the data table there are some blank rows. So in R, Excel, what it does basically, it knows it may not have any value in those rows, but still it's going to save it as part of this table. And when you load the data Excel file in R, it actually loads all those blank rows, and it's going to show you some extra rows. Let's say in this air quality data set, now we can see we have 153. Let's say it has 7 more blank rows. So we're going to see there are like 160 observations, but practically there are only 153. So when you do that tail function, you have an idea that what is exactly at the end of this data frame. If you have any kind of problems like that, you're going to immediately see what is going on in the head and tail of that data set. Okay, so moving on to the next step. So this step, we talked about that. What if your data set is really huge and you cannot really look at the actual data? It doesn't make any sense to look at the actual data. Then we want to look at the summary view of the data. So two of the most common, we're going to talk about 2 of the most commonly used summary functions. One is called a structure, str. So str function actually gives us a basic summary about the structure of this data set. So what it means is that it's going to print out all the column names. So here we have total is 6 columns, and then it's going to show us what kind of data this column is this column contains. So we see all these columns, they contain either integer or number. So in our double, meaning any number that has fraction in it, it's saved as number or numeric values. And if the values are just integer, it saves them as integer. And if you have, so in this data set, we don't have any strings. So you may also find strings or factors as the data type populating here. And on this part, it gives us some sample from the actual data, which is, I don't find this values very, very useful and everything. But anyways, so the best thing that, most important thing that we get from this structured function is that the names of the columns and their type of the data that they're storing. For example, if you look at that month, so month is 5, meaning it's storing months, and let's say 5. So here 5 means May, month of May, and it should be actually a factor. It's not integer, right? These are they're a factor. It's like January, February, March, April, May, June, July. So they're very much, they don't have any order. They have an order, but the order doesn't mean anything like magnitude or anything. So here they should be considered as factor. So right after you run this function str air quality, you know that one thing that you know that you need to convert this month variable into a factor variable from numeric. Otherwise, it's going to consider these as actual numbers, and it will use them to do calculations, which we don't want to do that for months. Anyways, the second most used function probably is summary. So summary gives us another summarized view, but it's a different view than a structure. So what it does, it gives us this mean, first quartile, then median, mean, third quartile value, maximum value, and number of innings. So it's basically these values. So for each of these columns, they give us this 5 or like how many, 7 different criteria of the data. So the ozone values, they range from 1 to 168. The first quartile value is 18, median is 31.5, and mean is 42.13. So from looking at this mean and median, if this ozone data was really bell curve, then we would have seen that median and mean be very close. But here we can see it's not that close, meaning their distribution is not bell shaped. And also we can look at the good thing about summary function is that it gives us the numbers of NA values that we have under each of these columns. So we can see that in this dataset we have NA values in ozone and solar columns. So this summary function is really useful. You should start any analysis with summary function. And then there are some other functions or other libraries that we can use. So summary and structure, these are base R functions. We don't need to have any library installed for that, but we can take help from other libraries too. So there is one library is called Schema. Schema comes with a bunch of useful functions, and the way we can look at the available functions inside a library is that you write down the name of the library, and then you use 2 colons. And then once you do that, hit tab and you'll see what are the different functions available there. So in a schema, the function that we're going to look at is called a scheme. And a scheme is basically, it gives us combined output of summary function, dim function, and a structure function, and something more. Let's look at that. So once we run that code, we see it gives us the data summary, which gives us name of the data frame, which is air quality, number of rows, 153, number of columns, 6, column type, frequency, numeric. So all those columns are numeric, so it's giving us all 6 columns are numeric. If we had factor columns, it would show us factor and how the number of columns that are factor type. Group variables, there is no group variables in there. And then we get this detailed view for each of these columns. So for ozone column, we have n missing, meaning how many missing values we have is 37. Complete rate, so meaning is like how many, so out of total number of total 153 observations, about 76% rows or they have some value. And then mean is this, standard deviation and stuff like that. And then the nice thing is you get a histogram. So from that histogram, we already saw that ozone has mean and median, different mean and median, like quite different, meaning their distribution was not really a bell-shaped one. And we can see histogram there, which also proves the fact that the distribution is skewed. So that's a really great function from a schema. Which gives us initially head start with understanding the data. And also in a schema, there are some other functions too we're going to look at. So let's say it has this function called nMissing. So what this nMissing does, so it also shows us this scheme function, what are the missing values are coming from, but we can get those missing values more specifically. So air quality, we're going to get total how many missing values we have in this data frame, meaning how many rows have some sort of missing value in there. So it's 44. And the benefit of using it this way is that you can use that for some calculation, right? So we can multiply that by 2 and we can get 88. An interesting thing about this, or call it, is that we can use it for specific columns too. So for ozone, we have 37. So this is really cool. This is really useful. The next library that we're going to look at is called Data Explorer. And this Data Explorer, it's another really, really fun library to use too. And it comes with a bunch of useful functions. So we're going to look at a couple of those. So first one is, let's say, plot hist. And then we're going to give it air quality dataset. So what it's going to do is that it's going to create histogram plots for all the features, all the numeric features in the dataset. So that's a really huge performance booster because you don't have to create those histograms one by one. So immediately we can see the data, the day column, which has really super high value for its like 14th day. For month, it's pretty much same. There is not a big variation. For ozone, it's skewed. For solar R, we can see there are some big drops in the middle. And temperature is kind of funky, and we can see that it's kind of bell-shaped, but if you change the bin numbers, it'll give us a better idea. So you get the idea that using just one line of code, you can create a bunch of histograms for all the numeric values, and you can get an idea about their distribution. And also you can create bar plots. So what it does basically, plot bar. So histogram creates histograms for the numeric values. Bar plots create basically count plots for all the columns, all the features which are factors or which are not numeric. Since in this column, in this data set, we don't have any non-numeric features, it's not going to create anything. It's going to throw us an error. So I just wanted to show you there is another function which is called bar plot, and in your data set, definitely you'll have some factor variables and which will be plotted by this plot bar. The last function that I wanted to show is plot missing. So plot missing is in your data set, if you have any missing values, this air quality, this function plot missing is going to plot those missing values for you, which becomes really, really useful in practically in any data set that you're going to encounter in your life. They will have some sort of NA values in them. So here in this data set, we see that solar R, it has about 4.6% of missing value. Ozone has 24% of missing values there. So this is really helpful in terms of giving you a head start about understanding your data set and stuff like that. So that's all for this tutorial. In one of those future tutorials, I'm going to talk more detail about how to look into missing values, specifically NA values. And then we're going to talk a lot more about this plot missing, and we're going to talk about some other fun libraries too. Thank you for watching this tutorial. See you in the next tutorial. Bye-bye.